Good morning, sir.
Good afternoon,
Director,
sir.
sir.
Good afternoon, sir. Good afternoon.
Good afternoon,
Good
sir.
afternoon, everyone. Good afternoon. Yes, please, Sanji.
Yes, sir. Yes, sir.
Okay, so good afternoon to all. With great pride and immense pleasure, I, Dr. Vivek Asati, warmly welcome you all to the 4-day international workshop on molecular dynamic studies using Amber software, organized by prestigious ISF College of Pharmacy, Moga, scheduled on 8th, 10th, 12th, and 15th November 2025. On behalf of ISF College of Pharmacy, Moga, Punjab, welcome to respected Director Dr. G.D. Gupta sir, ISF College of Pharmacy, Moga. Your guidance not only directed our work but also inspired us to achieve more than we thought possible. Dr. R.K. Narang, Principal ISF CPR, our eminent speaker Dr. Mahindi Irani, Associate Professor, University of Kurdistan, Iran, delegates from University of Kurdistan, faculty, members, and dear participants. We would like to say thanks to respected Sri Praveen Gargji, Chairman ISFCP, for giving platform for conducting such workshop. This workshop brings together learners, researchers, and professionals from across the world to deepen their understanding of computational drug discovery and molecular dynamics as an exciting field shaping the future of scientific innovation. Dear participants, we are deeply honored to welcome today's distinguished speaker, Dr. Mahindi Rani, an eminent scientist and expert in the field of molecular dynamics and computational chemistry. Dr. Mahindi Rani is an associate professor of theoretical chemistry at the University of Kurdistan, Iran. His research interests lie at the intersection of quantum chemistry, molecular dynamics, and multi-scale modeling, focusing on elucidating reaction mechanisms in enzymes and biomolecular systems using quantum mechanics and molecular mechanics methods. He has extensive experience in developing and applying computational chemistry workflows using Ember, Orca, Gaussian, and related software packages. Dr. Rani has published numerous research articles in reputable journals, including Inorganic Chemistry, Biochemistry, and Journal of Chemical Theory and Computational, covering topics such as metal enzyme catalysis, reaction energetics, and protein structure functional relationships. He is also the developer of PDB to Orca, a Python-based toolkit for setting up multi-scale QMMM calculations in Orca, and has conducted several international workshops on computational chemistry and molecular simulation techniques. Dr. Irani is deeply committed to advancing computational approaches for understanding complex biochemical systems and enjoy mentoring students and researchers in the principle and practices of modern theoretical chemistry. Thank you, sir, for joining with us. Let's us warmly welcome our esteemed director, Dr. G.D. Gupta, sir, to enlighten us with his words. So, welcome you, sir.
Thank you. Thank you. So, thank you very much, Dr. Vivek Asati ji. First of all, on behalf of ISF College of Pharmacy, I warmly welcome Mehdi Irani ji. He is the Associate Professor, University of Kurdistan. This is in Iran. So he is a very dynamic and dedicated personality in the field of the pharmaceutical chemistry. One core of my heart, from the whole of the ISF family, I welcome you, sir. I also welcome all these dignitaries and registered participants, those who are the connect. This is the online of this workshop. So first of all, I am thankful to our management to provide this opportunity to work, so to conduct this types of the workshop. So obviously, Dr. Vivek Asati ji, he is given the lot of information related to Dr. Irani ji as well as the workshop. So as you know that this is the era of the molecular biology and molecular system types of the study. So obviously this workshop, it will be the helpful to the each and every participant, those who are involved in the molecular dynamics, simulation studies like that. So in this workshop, we will provide some of the information about the expert, how to use the Ember software and how this is the advancement for the you can say number of the things you can find out how you can to execute analyze of the simulation technique or the biomolecular system and so many other things you can find out or you can learn during these 4 days. So I request to all participants connect regularly, listen carefully, because this is the online system and also related to the direct computer application. So software is the running on the computer. You can each and everything is the point out and you can find out what types of the queries you have. You can note down it and at the end you can ask with the expert. So our team members they are full time available. You can send your question also on the chat box. So without taking time, I am again thankful to the whole of the team, ISF College of Pharmacy and coordinator Dr. Vivek Asati to provide this opportunity to interact such types of the wonderful of the speaker. And we are going to organize this workshop under the MOU with the university, and I hope that it will be the helpful to the each and everyone. So thank you very much and good luck and good wishes to the all participants as well as the organizing committee. Thank you very much.
Thank you, sir, for giving your valuable words. It's time to give workshop details. So the title of the workshop is Molecular Dynamic Studies using Amber software, organized under MOU between University of Kurdistan, Iran, and Department of Pharmaceutical Chemistry, ISF College of Pharmacy, Moga, India. This international online workshop provides a hands-on introduction to molecular dynamic simulations using Amber software package. Participants will learn how to model, run, and analyze biomolecular systems, including proteins and protein ligand complexes relevant to drug design and biochemistry. The workshop emphasizes both theoretical understanding and practical application, guiding attendees through every step, from system setup to trajectory analysis to ensure they gain comprehensive skill applicable to their own research. Workshop will complete in 4 sessions. Session 1 include theoretical foundation and AMR installation on the 1st on 8th November. Session 2 that related to protein system setup on November 10th. Then session 3rd will be conducted on November 12th related to running and the MD simulations, and session 4 trajectory analysis and interpretation will be conducted on November 15th. So let's start the session. May I invite Dr. Mahdi Irani to please enlighten us with your address and expert session. Welcome you, sir.
Thank you very much, Dr. Vivek Asati, for your nice introduction. You introduced me very good, and also the workshop. I would like to thank the other organizers and chairman in the ISF College of Pharmacy. Okay, let me share my screen and then turn off my camera for a while. Okay. Do you see my screen now? Welcome everyone for the International Online Workshop on Molecular Dynamics Studies using Amber software. As Dr. Vivek Asati said, this workshop is organized in 4 sessions. In session 1, we will learn theoretical foundation of molecular dynamics and installation of Amber program. In session 2, which is on Monday, we will set up a protein system for molecular dynamics simulations. And in the 3rd session, we will learn how to run molecular dynamics simulations. And finally, the last session, which will be on next Saturday, we will learn how to analyze trajectory and interpret the MD results. It is important that we install AMBER program for the upcoming sessions. Especially, we will need the AMBER program for session 3, which is on Wednesday. Subjects that will be covered in this session is an introduction to molecular dynamics simulations, why we perform it, basic idea behind MD simulations, force field concept, energy function concept, common force fields for biomolecules, thermodynamic ensembles, periodic boundary condition in molecular dynamics simulations, solvation and ionization of a biomolecular system, energy minimization before equilibration and production runoff, MD simulations, and finally we will overview AMBER software and we'll learn how to install AMBER. Okay, what is molecular dynamics simulations? It's a computational method that simulates atoms and molecules based on Newton's equation of motion. As you know, when we get a protein structure, for example, from protein data bank, they are fixed structures like this, but actually in nature they move, they vibrate. Molecular dynamics simulations is like a microscope that lets us to watch biomolecules. I have selected a few videos from some friends that performed molecular dynamics simulations. These videos make us familiar with the concept of molecular dynamics simulations. For example, as you see here, this is an output, visualized output of molecular dynamics simulations that shows how different parts of a protein moves during time, and you see a ligand that moves inside the protein during time. And here also you see movement of a biomolecule, which is a protein during time, which is obtained by molecular dynamics simulations. And here also you see another that's how an organic molecule moves during time. All of these are obtained from molecular dynamics simulations. Okay, why we perform MD simulations? MD simulation bridges gap between structure and function of biomolecules to compute physical properties like energy, temperature, pressure, kinetic energy, and other quantities. Its application is in drug design. I know that scientists in ISF College use MD simulations for drug design. It can be used for studying protein ligand interaction. For example, here you see how a ligand interacts with a molecule from which amino acids residues a ligand interacts with the protein. And also it can be used for studying enzyme catalysis. Okay, a basic idea behind MD simulations. In MD simulations, atoms are a system treated as point masses with a mass of M1, M2, and so on, and electrons of the system are neglected. It is a completely classical treatment. We know that actually atoms are composed of nuclei and electrons, but in molecular dynamics simulations, all of these are neglected, and the atoms are treated as simple masses with partial charges of partial positive or partial negative charges. Interaction between two or between these particles in the system are described with classical relations. We use Newton's equation of motion for to obtain dynamics of the system. What we need in molecular dynamics simulations is the coordinate of atoms, which in biomolecular systems it can be obtained from a protein data bank. We need R and also initial velocities. At the beginning of the simulation, it is 0. The velocity is 0, but we have to obtain initial coordinates from protein data bank. After that, we can calculate potential energy of the system, which is a complicated function of coordinates of each particle in the system. After that, then we have here VR. Knowing VR, we can calculate force on each particle. We know that force equals minus gradient of potential energy. Then this gives us the force applied on each particle. Knowing force, we can calculate acceleration of each particle, because we know that F equals ma from the second law of Newton. Then a, or acceleration of each particle, equals F divided by m. Then knowing a, we can integrate it, we can obtain new velocity of the particles, which is equal a dt. But this integration is very complicated, and this integral is very complicated and has to be solved by numerical methods. After that, this gives us a new velocity. For example, if the first velocity was v0, the new velocity is v1, for example. Knowing v1, we can calculate the new position of the atoms. If the new initial position, for example, is R0, this will give us R1, and so on. We can continue this cycle to obtain new coordinates and new velocities, and do this so on until we reach the desired structure as far as our hardware allows. Then we obtain the first coordinate is R0. After one cycle, we will reach R1, and then we reach to R2, and so on, collecting coordinates of particles. At each time, we give you will give you the trajectory of the system. As we watched trajectory of a system here, of a biomolecular system here, which is obtained by performing molecular dynamics simulations. And what is important is the time step in this integral, which normally is between 1 and 2 femtoseconds. Multiply number of iterations by the time step will give us the total time of the MD simulations. Okay, force field or potential energy that we talked here in this slide is one of the important concepts of molecular dynamics simulations that is a complicated function of a coordinate of system. It has bounded terms, which include bond stretching, angle bending, and dihedral torsion, as you see their equation here, their equations here, and non-bounded terms, which are van der Waals and electrostatic terms. What we need for at the beginning of the molecular dynamics simulations is to calculate potential energy of the system. Another name of the potential energy is the force field, or we have to calculate force field or potential of the system. Sorry. Okay. Then different force fields are available to treat biomolecular systems. I listed some of them here. Amber is a common force field to treat biomolecules like proteins, DNA, RNA, and ligands. Charm is can be used for treating biomolecular and material systems. OP-LSA can be used is suitable for organic and biomolecular system, and GROMOS mainly used for coarse-grained and aqueous systems. In this workshop, we will use Amber FF19SP force field, which I provided the title of the describing article here. We will use this for proteins and GAF2 for describing ligands, or ligands that we dock into our protein. These are the latest force fields, as far as I know, that are available for Amber users. Okay, then depending on experimental condition, simulations can be performed in different ensembles. We have three main ensemble types: NVE, NVT, and NPT. The term N here refers to particles, or number of particles in the system, which means that number of particles are constant during the simulation. V refers to volume of the system, and P refers to pressure of the system. T here refers to temperature, and E refers to energy of the system. We can perform simulations in any of these ensembles. They have keywords in Amber. We can select any of these depending on our experimental conditions. For biological system in which experiments are carried out in constant pressure and constant temperature, we used NPT ensemble, which is described here for simulations. We also use periodic boundary conditions to simulate the system. It simulates a small system representing bulk behavior. The system is enclosed in a box that you see here, and and this box repeats infinitely in all directions, in X, Y, and Z directions. In this method, when a particle leaves box from one side, the particle enters to the system from the opposite side. This strategy allows us to perform simulations much faster And however, it is also possible to perform simulations in non-periodic system, as you see here. In a spherical, we can also perform simulation in a spherical system, but this type of simulations are erroneous and slow, but we normally perform simulations in octahedral system, as you see one of them here, in octahedral boundary condition system. All of these have also options in Amber program to switch between them. What we need for molecular dynamics simulations is salvation of the system, because as you know, proteins in protein data bank are not salvated. In data banks, only the initial structure of proteins are reported. However, there might be some crystal water molecules in the system, but it is not enough for simulation. Before simulation, we have to salvate it by a molecule, as you see here. We have to salvate it for the simulation. And sometimes we need to add counter ions like Na plus or Cl minus to neutralize the system or them the desired ionic strength. Good. After salvation, the biomolecular system, we have to perform energy minimization. Energy minimization, as I said here, removes steric clashes and bad contacts, moves system to a local minimum, as you see here. At the beginning of the simulation, we are here, and look, minimization lets us to move to a local minimum. There are different algorithms for this, for energy minimization, which we can choose during our calculations. If I want to give an example, suppose that we have two water molecules in our system. At the beginning of the simulations, the other water molecule is directed like this. As you know, this is not energetically favorable. This has a high energy. Its energy is high. For example, it is here. Minimizing it will rotate the water molecules so that the first water molecule interacts with the second water molecule with a hydrogen bond. It's oxygen of the first water interacts with the hydrogen from the second water molecule. This allows that energy of the system become lower. If we don't perform this, we will encounter errors in the following steps. After energy minimization, we have to perform equilibrium and production. First, we equilibrate system, gradually relax the system to target temperature and target pressure. Then that's right here. We first perform minimization. After minimization, or it's better to write energy minimization. Energy minimization. We perform equilibration. Equilibration to reach the desired temperature and pressure. After equilibration, we run the production MD. Production MD simulation. And from the production MD simulations, we obtain the trajectory of the system, and after that we can analyze trajectory of the system, obtain, for example, we can obtain RMSD of the system, RMSF, and other quantities relating to the system. In Amber, we perform this using a module which is called CP PT-Rush. Okay, and limitations and challenges of MD simulations. The first important challenge is time scale limitation, which is up to microseconds. We cannot perform MD simulations for seconds or minutes. We can perform simulations for nanoseconds and microseconds. The other limitation that it treats the system classically. As I said before, it ignores electronic configuration of the system and considers particles as point masses with partial charges, partial positive or negative charges. And another limitation is that it's computationally expensive, requires HPC resources and also GPUs to perform MD simulations. Okay, and Amber software is one of the programs that we can use it to perform molecular dynamics simulations. It has been developing since 1970s. I have listed some links here. We can check them. The first link is the official website of the Amber program. I will share these links with you after the workshop in an email or in the WhatsApp group. As you see, the latest version of the Amber program is Amber 24. In this link, you can see the history of the program. You can read this page to find out the history of the program, who has started writing this program and how it is being developed during time, and the people who contributed to the project. Almost every year we have one version of the program. In 2013, 2014, 2015, and the latest version of the program is was released in 2025, and also who contributed to the project. We can see it on this link. You can find also some information about the force fields and people that developed the force field modules of the program. In this workshop, we will use the TLIP module and the chamber module, also Sander module, in the upcoming sessions, and so on. Okay, and at the end we reach to the most important part of today's session, which is Amber installation. I suggest that have a short break for 5 to 10 minutes and continue after that. It's 12:41 now. Let's continue at 12:50.
Please, participants, wait for 5 minutes.
Okay, sir.
Do we need to put any kind of attendance in chat box?
Okay, we can continue now. But first, I need to know if you have worked with Linux operating system. Are you familiar with Linux operating system? Please let me know, writing yes or no in the chat box.
Participants, if you are aware about Linux system, then you just write in chat box.
Good. As far as I can see, most of you hasn't worked with Linux. Now, please let me know if have you worked with a Mac system.
Sir, actually, the pharmacy students do not aware very well aware about Linux and Mac system. So probably maximum candidates do not aware about Linux system, but they know about molecular dynamic study and related software. So just you can proceed.
Most of them work with Windows. Is it correct?
Yes, absolutely.
Okay. Let's continue to know how we install it. Install Amber on a computer. Let me share my. I think my screen is shared. The Amber program is actually developed for users that use Linux operating system. However, there are some way to install it on Windows. To install Amber on Windows, you can install Ubuntu Linux virtually on your Windows. As far as I know, there is a software which is called VMware. Which, yes, I think it is this one, which allows you that install different operating systems virtually on your Windows. And another alternative is the WSL of Windows. You can easily install Ubuntu on WSL, searching Ubuntu. This machine is also a Windows machine that I am presenting. I have already installed Ubuntu. If you haven't installed already, it will help you to install Ubuntu. Then you will encounter with a terminal like this. If you have access to a Linux machine, that it is much easier to install Amber. For Mac systems, it's also the same. What you need is to open a terminal and execute some commands. For installation, you can, let me open here. You can refer to this page, Amber download page. I share its link with you. Sorry. Let me open here. I share the link of this page with you. This is a procedure, a customized procedure that we use to install Amber on our systems. Here we explained how to install Amber. We have a small introduction introducing Amber, that it's an assisted model building with energy refinement, is a suite of programs for biomolecular simulations. Its project began in the late 1970s and has been maintained by an active development community. It is a powerful tool for performing molecular mechanics optimization and molecular dynamics simulations. Amber can also perform other classical calculations such as MMPBSA and MMGBSA to estimate ligand binding affinity. Here is its official web page, and in the following sections, I outline the customized installation procedure for the latest version of Amber Tools, which is Amber Tools 25 and Amber 24 on Ubuntu Linux. For more details, visit the official Amber download page and consult chapter 2 in the Amber manual. That you can download Amber manual from this link, as I included the link here. After downloading it, you can refer to chapter 20, which explains how to install Amber. Let's follow the procedure from my web page. First of all, we need to install CMake and required packages. After installing your Linux on your Windows, or if you have access to a Linux machine, this is a Linux machine that I have. I follow the procedure here, and also on Linux, on Windows, using this, using this terminal. The first step is to switch to a root user. You can copy and paste this command from here. Copy this command and paste it in your machine. Sudo su. Then what you need is to enter your password. You need to be a sudoer to switch to root user. Also, I executed here, writing sudo su, which switches to the root environment. After that, it asks for password of your machine. In the second step, you need to install some packages. First, you need to update your system. Then you can copy the commands one by one and paste it here in the terminal. It will connect to internet and update your system. Also, let's also perform that one here. I think this computer is not connected to internet. Let me connect it to internet. In Linux, you can easily connect to a VPN using this command. I connect my Linux machine to internet. Okay, after that, I update my system. As you see now, it works because it is now connected. Then I copy the next command and paste it in terminal of my Linux machine, and also in my Windows machine. Okay. it will be completed depending on your internet quality and your hardware. Then let's go to the next step. We install CMake, just copy and paste it. Then install other packages. You can copy them all. Do it at the same time. Okay, then let's do it also here. The Linux that I have on my Windows is not up to date, then it takes much longer time to update the system and install the necessary packages. Let's continue from here. After that, we need to download Amber Tools. Going to this page, the download page of Amber. If you visit this page, there are two packages for download. The first one is Amber Tools, which is necessary for our purpose, for the purpose of this workshop. However, you can also install Amber 24 software, especially if you have access to an HPC center to run simulations on GPUs and use much faster features of the program. What you need is to fill in this form and download the program. It's 583 megabytes. Okay, I downloaded it to my downloads directory. No, sorry, it's not here. It's on another computer. I copy it here from, I think, this yes, I copy it from this computer. CD downloads. Yes, you need to download these two files and move it to your downloads directory. I have already downloaded it and move it to this computer. You can use the SCP command to download, to move one file from one computer to another one. Okay, let's wait for a few minutes to copy the file to this computer. Okay, also this one is upgraded. This computer is also upgraded. I can perform the following steps. Okay, copy these and paste them here and let them to be installed. Read the messages carefully and execute the appropriate options after that. Okay, let's return here. Okay, 90% is completed. As you see, there are two files here. What, as I said before, what we need for this workshop is the first one. Then we can return to the root user and follow up the procedure. After that,
Sir, please describe one thing that do not understand to student. How we go to this root user?
to the root user. Okay, let me repeat it. To switch to root user, what you need is to execute this command sudo su on Ubuntu. After that, the system asks for the password of your computer. If you enter your password, you will switch to root computer. My password was wrong. I try it again.
So
Now-
where we get this password?
When you install Ubuntu or when you activate WSL on Windows, you define the password.
Okay,
Everyone knows his password. As you see here, now this is root. We switch to root, but before that, it was not root. It was Mehdi, which is my user. Okay, let me repeat it again. Sudo su, then enter your password. Oh, sorry. Here is the root environment, which you can update and upgrade your system. Okay, let's return here, which I open the root environment, then follow up the next session, the next step. Let's return here. Okay, then I switch to change my directory to opt directory. As I said here, move to opt directory and extract the tar.bz files using the following command. Okay, then I copy it here and paste it in the terminal that my root user is active. cd opt. Okay. After that, we need to extract the files that I downloaded here in the opt directory. To extract the files, you can use this command. Okay, I copy this command. And then I give it the path to the files, which was in home. If you want to know your working directory, the directory that the files are located, you can go to the directory and execute pwd, which shows you your working directory. Here you can copy or paste it to here, or you can type it Mehdi, and then downloads here. And in this directory, I want to extract this file. Okay. This might take a few minutes, then depending on your hardware. If you cannot follow the procedure in this session, you can try it after the session. We have 4 days to install Amber. As I said at the beginning of this session, that we need Amber program for the Wednesday, the session on Wednesday, because on Monday we don't need this. As you see, the file that I downloaded is extracted. It is extracted here in this directory. You can optionally also extract the other file, this one. But as I said, for this workshop, we don't need to extract this. Then we can go to the 4th step. Let me read this comment here. If you do not have the PMEMD24.tar.bz file or do not uptake it, you could proceed the installation, but at the end you will be able to use some features of the program. You will not be able to use some features of the program. However, you will be able to use necessary modules that are proper for setting up and running these simulations. Okay, step 4, apply patches. For this, we need to switch to this directory. You can copy this command and change your directory to Amber Tools 25 _SRC directory. After that, we can update Amber. This step optionally can be done. It's not very important, but I try it. Oh, sorry, here. I think that here is a spelling error. We need to add a space between help and update Amber. I will update the manual and correct that mistake here. Then I execute the command once again. Okay, and there is also a spelling error in the second command. I copy it here and paste it here. What we need is that here include 2 dashes. 2 dashes dot slash update underline Amber dash dash update. Okay, this is also completed. Then let's go to the next step. As I said before, skip this step. Then I come to the fifth step, which is run the CMake script. To run the CMake script, I change my directory to opt Amber Tools 25_SRC build. You can copy it here and paste it in your terminal. Okay, now as you see, my working directory is opt Amber Tools _SRC build. After that, run CMake. This step might be very long. It might take 1 hour or more, depending on the hardware. We cannot wait for it to be completed, but after the session, you can continue installing. When this step is completed, you need to execute the next upcoming command, which is make install. But we can continue from here. From step 6, which is to add Amber to your .bash RC file. To do this, you don't need the root environment. What you need is to switch to your user and add the Amber path to your shell configuration file. Then I switch to or open another terminal with my user, not with the root user. Then I copy and paste the commands from here. As you see, the cd command returns me to my home directory, and echo command includes this into my .bash RC file. Let's check the .bash RC file by the less command, less.bash RC. As you see, it includes this line at the end of the bash RC file. And after that, I include another line to the bash RC file. I copy it here and paste into my terminal. After that, I check my bash RC file. As you see, this command added this line to my .bash RC file to let me use Amber. But to activate Amber in my terminal, I need to also execute this command. I copied and paste it here. It says that there's no such file or directory because the installation process hasn't been completed. When this step here completed, then Amber will be activated in my user. Okay, let's open another root user. Yesterday I completed the installation in another computer. Let me show the installation files on that computer. Here I switch to opt directory. As you see now, after running make install, I will have this directory. In this computer, I can continue the following steps from step 7. But let's switch to my user in this computer and perform these steps from the beginning. In this computer, I have a root environment. I also open a normal user environment. Then I paste the comments here. As you see, then let's dash RC. Okay, let's see. End of the bash RC file. As you see, we added commands for running Amber to the .bash RC file. Then let's go to step 7, which is activate Amber for users. We need to assign permission and activate Amber for users. You need to add a group named Amber into your computer in the root environment. I have already done it for my user, as you see here. If you execute the ID command, you can find which groups you are part of. It, as you see, there is a group which is called Amber, and its ID is 333. And I am a user in the group of Amber. However, if you haven't already done it, you can easily copy these comments here and paste them into your root terminal. As you see, it says that group Amber already exists. Then I can go to the next step, which I add my user to the Amber group, user mode -A-G Amber Mehdi, and I paste it here. Then it again says that you have already, as a member of the Amber group, as I showed you here. Then let's go to the next step, which we need to go to the opt directory in the root environment, cd opt, and give the necessary permissions for the newly created directory. This allows the users to have necessary permissions to run the Amber program. Okay, and the last one. And the last step, which is optional, is not necessary for this workshop. I skipped that one. There is a spelling error here. I will correct it after the workshop. Then I can rerun my .bash RC file and check if the Amber is installed or not. As you see, Sander, which is one of the modules of the Amber program, is installed here. We will use it on Wednesday. And TLIP also is installed here. And the other program, anti-chamber, which we needed for parameterizing our heterogroups like ligands. It's also installed. Okay, let's get back here and show and see what's happening. Okay, in summary, we introduced MD simulations and introduced force fields, defined potential energy surfaces. And we said that MD links the structure of a biomolecule to its dynamics, its functionality, dynamical functionality, and AMBER provides a comprehensive platform to visualize dynamics of a system. Before the next session, I suggest that you watch some videos that explains basis of molecular dynamics simulations. I will share this link with you after the meeting. However, I can also share it now. Let me find its link from here, from the Word file of the slides. Okay, I copy it here, copy hyperlink and paste it in the chat box. And also, if you have any question about installation or other aspects of this workshop, you can enter your question here in this form, which I share its link with you in the chat box. And also you can, what happened? You can also ask your question after the session in the WhatsApp group of the workshop. For the coming next session, we will set up a protein. We will choose a PDB file and set up for molecular dynamics simulations. We first will clean the PDB file. We'll know how to treat crystal water molecules inside the PDB file, how to handle missing residues and atoms in the PDB file, and how to resolve alternative locations and check for short contacts and so on. In the next session, we will move from theory to practice. Okay, let's get back to the class and okay, see what's happening. To me, it's enough for today, Dr. Vivek. If there is any question or any comment, I'm here to answer.
Audience or participants, if you have any type of query related to this installation of AMBER software, please ask. You can write in chat box also, or you can directly ask to Dr. Mahindi Iran. So this is my humble request to all participants.
So do you hear me? Okay, I think that there is no question for now. Try to install the Amber program. I am sure that you will encounter with too many questions. When you encounter the question, please add your question in the Google Doc that I shared its link with you. Please include your question in the left-hand column of the table. I will answer your question in the right column. And you also can ask your question in the WhatsApp group.
Sorry, sir, for interruption due to some network problem.
Okay. I said that I think that there is no question for now, but I'm sure that the participants will encounter many questions when installing the Amber package. They can include their question in the Google Doc that I shared its link. However,
Few students asking what force field you are using for running this Amber software.
worked from the commands for installing the packages. As I showed you, you will run the commands here in terminal. You need to install Ubuntu on your Windows machine. Let me share a link with you that explains how to install Linux on Windows. I think, yes, it's this one. Let's open the link. Okay.
Where to run the commands for installing the package?
Okay. After you activate your WSL, you have to install Ubuntu, as I have already installed it on my Windows machine. Then we will execute all the commands here in this terminal, in this black terminal here. However, I share the link of this page here.
Another question, participants. So if you have any query, you can further message in WhatsApp group, or you can email to Dr. Mahdi Rani also. So thank you, sir, for this first day session, and really you given a lots of details installation of this Amber software. I think that is very basic, and everyone understand how can we install, because you in a simple way you describe the all things. So thank you, sir, for connecting, and the next session will be start on the 10th November at 2 p.m. So 2 p.m. According to the Indian time. So kindly connect, and further we tune for the next process of this molecular dynamics. So thank you, all of you. Thank you,
Thank
Dr.
you very much for hosting me, and thank you all the participants. See you on Monday.
Dr. Vivek, you are requested to please off the recording. You can stop the Google